Hey, what's up guys? This is part 2 of my video figuring out the material change for the C-hub and the caster blocks that we failed on the speed runs earlier. This will be a short one, so stay tuned. Alright, so first test, 255 degrees did the best, raising the hammer all the way up to 30 degrees from horizontal before it cracked. 245 right behind it. Both those temperatures did not experience as much layer delamination. 235 was by far the worst out of all the tests, with a brittle failure and layer delamination below a 60 degree, because it was the first test and it broke. So the next material is Tallman Bridge. All temperatures did not experience any layer delamination. 235 degrees did the best, having to raise the hammer all the way up to horizontal in order to break the material. 245 and 55 broke at 20 and 30. It seems like as temperatures increasing, the more brittle this material is becoming. All right, so next phase of testing, all tests from here on out will be dropped from 0 degrees. On the upswing, what we're measuring, first test was 235, came with an upswing of 52 degrees, which is a good thing. The lower the upswing, the better. 245 and 255, you can see as temperatures increasing, the effect is worse. Same thing we saw in the last. And finally, Tallman Bridge, all specimens exhibit the same kind of failure. There's no layer separation. 235 outperformed the rest. As you saw, we could not fail the material. We had to change the direction, clamp it harder. It cracked, but it just did not fail at the smaller cross section. 245 and 255, the raise in temperature there, we did see an adverse effect. So we compiled the data. First is the downswing energy on top, compiling all the results from the first round of pictures there. Nylon 12 to 235 is the dominant choice. And then the impact energy absorbed, so how high the hammer got after the impact. We see that the nylon 6, 235 nylon absorbed the most. Both of those are sky high. Obviously nylon 12 was the winner here, but focusing on nylon 6, the temperature is 245 and 255 for both materials. As temperature increases, we're seeing less impact energy or impact strength. So good thing to point out. All right, so we're going to go forward and apply this material and the temperature of the printed at to those parts and get the car back up and running. All right guys, that's going to do it for this video. Thank you for watching. We got the material picked out, the temperature printed at, so we're going to get this thing fixed up. When we get the motor in, we'll get it all running again and play with the pinions that we think are going to make this thing go fast. Maybe do a couple more speed runs. So stay tuned for future videos. Please like and subscribe. I appreciate it, and have a great one. Bye.